Hi, we want to take a look at quadratic graphs. In this case, we want to look at translations as it involves quadratic graphs. Translations are simply shifts, horizontally or vertically. So it could be that your graph has moved towards your left or towards your right. And it could also mean that they are vertical shifts, which means your graph has moved up or down. We want to take a look at what this means as it pertains to your graph and how we might use the knowledge of translations to find the equation of our quadratic function. Come along, let's see. The first thing we want to look at here is the basic graph. This is the basic graph y equals to x squared. This platform I'm using, as you can see, is GeoGebra class. Now, if I decide to apply a translation to this graph, I need to alter the equation of this graph. Right now, what I have is y equals to x squared. But let's say I just add 2 and I push on enter. As you can see, the graph here has jumped 2 units upwards. What if instead I add 6? As you can see, there is a gap from the origin up to this point, which is 6. Which means that if there is going to be a vertical shift, the constant term that we add to our equation right there ensures that vertical shift. What if there is a negative number? Let's say instead of plus 6, I have negative 2. What happens? As you can see from the origin, which is the point right there, it's moved 2 units downwards. This one is what we call a vertical shift. So when you see this, you see a constant term just by the x squared there, you know that it represents a vertical shift. Let's return back to the original position, which is y equals to x squared. Right now we have our graph back at the origin. What if we want to consider what horizontal shifts are? How does this affect our graph? Let's take a look. Now, for horizontal shifts, what I need to do is to use parentheses and put the square outside it because I will be altering the x. So if I want to make a horizontal shift, which is either moving left or right, I want to see what happens if I move to the left. Now, curious thing, if I'm going to move to the left, I need to use addition there. So I'll just use plus, maybe let's say plus 3. This graph, you will find that we move towards the left. You can see it's moved towards the left 3 units. From the origin, it's jumped towards the left 3 units. Okay, this is a horizontal shift. Let's say I want to move towards the right from the origin. First of all, let's return to the origin by returning back to x squared. This should return it back to the origin, yes. Now, if I wanted to make a right shift, again, what I need is to alter the x so that I have maybe, if it's a right shift, it's going to be negative. So x minus, let's say 3. X minus 3 all squared. This is what we want. And then we push enter and we see what happens. All right, you can see that from the origin, it's moved 3 units towards the right. All right, so if you want to move towards the right, that there will be a negative. That's this sign up here. And if you're moving towards the left, it's going to be a positive. All right. Well, I hope these parts have been clear. So far, I have used GeoGebra to explain the movements along the x-axis, which is the horizontal movement, either towards your left or your right. And I've also explained the vertical movement, either up or down. What we want to do now is to consider if we combine these 2 translations. What happens? Now, we want to combine these 2 translations, which means I want to combine the horizontal movement and also the vertical movement. Right now what we have is I have moved towards the right by putting negative 3 there. I've moved towards my right 3 units, as you can see from the graph. If I want to move up, I just need to add that outside the parentheses. So let's say I add 2. I expect the graph to jump 2 units. So as you can see from the position already taken by the graph at x equals to 3, y is 0, at that point there, it's now moved 2 units upwards to get to the point when x equals to 3, y equals to 2. This is what the combination of the vertical movements and the horizontal movements will do to your equations. Well, let's take a look at another example. First of all, to do this, it's best we return to our original position, which is y equals to x squared. So I'm going to do that and clear this graph. Now, what I want to do is to use a combination of both the horizontal movement and the vertical movement. So first of all, we may want to move horizontally. So let me produce a parenthesis here so that we can easily do that. Now I'm moving towards my left, which means I'm using addition here. Let's say I add 5. This one should make it shift towards the left 5 units. And as you can see, that's what has happened, it's shifted 5 units. Next, I'm going to move downwards by using a minus this time. So let's say I use -5 and then I hit enter. I expect that my graph has moved 5 units downwards. So as you can see, what we have here is a horizontal movement of 5 units towards the left and a vertical movement of 5 units downwards. All right. Now, as a recap, you will see that whatever we have here is what we call the vertical form of a quadratic equation. Let me just say here that if you need more classes on the vertical form, I have a lot of videos that you might want to take a look at. I have this video that I'm going to link up. Please check it and take a look. I trust that you will learn a lot more than what I'm doing right now on this. Okay, what we are going to do now is to take a look at some examples that will totally explain what I am talking about. So you've been given a quadratic equation written in vertex form. The question is, what is the axis of symmetry? Well, it's very easy to pick. What you need to do is to look at what you have here, and you know that the vertex of this graph, that's the first thing you want to do, pick out the vertex. The vertex is at -2 and 5. Now, the x value, remember that this one is always equal to x, y. So the x value, x equals to -2, is the axis of symmetry. Yeah, if you're wondering what the axis of symmetry is, I'm simply asking you, okay, this is your graph. X is -2, say, that's x equals to -2. We know the vertex is at -2 and 5, so let's put 5 here. And this should be the lowest value of our graph. So what it means is that the graph generally looks like this. Okay, I know I've not properly plotted that. So it generally looks like that. And that is the lowest point. So your axis of symmetry will be the line that cuts this graph into 2 equal parts. That line will go through x equals to -2. That's why we are calling the axis of symmetry x equals -2. Well, I hope this makes sense. If they're asking for the vertex, or already I've written it up here, so that's easily seen. Let's take a look at another example. Here's a second example. And it says if the vertex of y equals to x squared minus 2x plus k is 1, -3, what then is k? Clearly you can see that we have x squared minus 2x plus k, which of course is not written in vertex form. And the first thing we want to do is to write this in vertex form. Again, if you need an explanation on how this is done, I'll link the video right now so that you can see it. If it's not the same one I already linked before, if it's the same one, YouTube will not let me link that same video again now. So I might maybe link another one. Okay, but we're still going to go ahead and write this in vertex form. And the method we employ doing that is completing the square method. And how do you do that? You look at the coefficient of x. In this case, it's -2. You find half of it, which means you divide it by 2, and then you square it. So what we have is -1 all squared. This quantity is what I'm going to add to this part here to make it a perfect square. So x squared minus 2x is not yet a perfect square until I add -1 all squared. Now, because I've added something that wasn't there before, it's prudent to take it out so that, it looks like I've not added anything at all. So if I subtract -1 all squared, which is simply 1, I take that out and I add k, it completes my equation. Now, what I need to do is to write this trinomial as a square, and I do that by picking x and picking -1, and writing this all squared. Then the rest, of course, will just be plus k minus 1. For what I've written here, you can see that we can pick the vertex and say that the vertex is at 1 and k minus 1. So if we compare this with what we have been given, we were given 1 comma minus 3 here. So we can see that 1 and 1 are lines. What we need to do is to take k minus 1 and equate it to negative 3. And this gives us our k to be equal to negative 2 if we take negative 1 to the other side. So this gives us k to be negative 2. Well, I hope this video has been a huge help for you. I will put a link down below if you need some more questions to practice as it pertains to the vertex form of a quadratic equation and the translation of it. Now, if you need a more comprehensive package of questions for maybe something close to 100 questions, I've got another form for that one if that's what you're interested in. I hope to see you in the next video. You take care of yourself. Bye.